So today, the camera autofocus. Okay, everything is fine. Does the sound fine before we start? Yeah, I tried that with the hand, but it didn't work, so I had to deactivate it and activate it again. That seemed to have done the trick. So today, sounds good. Okay, then I'm gonna start. Thank you everyone for showing up. So today I'm gonna continue showing some aspects on how to develop your own text editor. Last time we replaced the GDI functions with our own software renderer version, so we can fill out rects and copy from one frame buffer to another. Today we are going to be using STB TrueType to load fonts and to rasterize them into our own texture atlas, and then hopefully display glyphs that we load with TrueType. So first of all, as always, well, let's just see if everything works. That's always good. So we build, and then we should have our main axis. So this was where we stopped last time. So we can, this one is just filling a rectangle region, and this is basically copying a texture which we created ourselves. So this is our amazing software renderer. And now we're going to load STB TrueType and see how we can load and rasterize fonts. So if you Google for STB TrueType, you will find Sean Barrett's single header file libraries. And among those, we also have STB image, which allows you to load from different texture formats, picture formats like PNG or JPEG. We'll be using STB TrueType. The cool thing about these libraries is basically you only need one header file, and all the code and all its dependencies is stored in one file. So you have very little setup. So all we need to do is basically download the raw version, like so. Let's just put it where we need it. Where is it? Yeah. Tutorials. So we are on day 3 now, and we're just going to place it in our source, in our code directory where all our source code is. Give it a proper name, and then basically all you need to do is in your wherever you wanted to use it, you basically just say include the file name, like so, if you spell it properly, that is. Let's first see if that compiles. Yeah, so that compiles, and now we want to actually use it. So let's just look at it. Also contains documentation and update changes and everything, so it's all in this one file. It's like 5,000 lines of code, but most of them is just annotations and yeah, documentation basically, and what changed. And we will be also, we have 2 examples like this one, which is excluded, but it should compile. So if you paste this in, you will get a functioning version. But we will not use the simple version. We will use the more custom version where we can pull out individual fonts. So this is also not the custom version, is it? Could be. Oh no, maybe it's this one. Yeah. So the first thing we need to do is to initialize the font, like so. So we need to create a stbtt font info font. I'm just gonna open these side by side so that we can look at them more easily. So which line is this? It's line 376. And then we go into our main axis, and we will add a new global state for our font. So here in our main function, before we enter the rendering loop here, we're just gonna add this font stuff, and then we should it says we should load a font, so it expects the font to be loaded in binary data basically. so that you just specify the binary data into the init font function. I think they have a version where you can load the font from a file directly, but we are gonna do we are gonna also manually load the font. So in order to do so, we need basically another platform function from Windows, and we can, since it's always the same code, I'm just gonna use some reference that I already have because I don't really want to re-implement everything every time. So I'm just gonna look at my previous implementation of how to read an entire file. This is how it looks, and then we will go over it and explain what the individual functions do, as always. First thing first, we're gonna create a new function. It's gonna call it platform read entire file, like so. Just gonna paste it in for now, and then we're gonna see what we need. Right now we don't have a platform struct or information, so I'm just gonna inline this stuff like the platform get file info, which is also something we probably don't need. This is only to make sure that the file actually exists before trying to open it. We can do that though. Then you also see how that works. So let's just take that portion too, and then we go over the functions. So first of all, get file attribute xa. As always, we'll Google it and just look at the documentation. If the Windows full screen function would work, actually. So if you look at it, it basically expects a C string, null terminated string as a file, and then some predefined info level that we have to specify. In our case, it's this is a constant. Yeah, basically the only thing that's supported, as you can see, is this one, so we have to specify this. And then the other thing is the output buffer, which should be, if you use this constant, it should be Win32 file attribute data, as we have created here. We have this data, then we have to specify a file name, so we I think we don't have a typedef for that. So what I usually do is I use typedef char pointer and rename it to C string, so that I can distinguish between normal strings that I use, like these that we've implemented here with which have a pointer and a count, and zero terminator C strings that are the typical strings. This basically is just an alias for using char pointer, and this way we don't have to specify this all the time, and we can make a more clearer distinction on what the data is representing. It's just how I do it. You don't have to do this. If you're fine with char pointers, you should just use those. So where were we? Here. So we will specify a C string file path. Sorry everyone if I'm not looking at chat. That's just how I do it because I cannot focus otherwise. So we have the file path, and I should have the same spelling. And then we try to open it and try to extract information from it without opening the file actually. We just we don't get a file handle for this. We only get information, so you can basically use this, and it should not fail if the file exists. And you don't have to deal with opening and closing handles, which is a more involved operation, basically. So all we do is basically if this function fails, then we should assert for now, because we don't really care. We expect this file to be there. So right now I just will assert that the file exists. And then we can compute the byte count, which is basically, if you look at the struct, you get the file size high and file size low bit. So you get a 64-bit value split in two halves. And then we reassemble them to one 64-bit value. This is how big the file is. And if we have this information, then we can basically allocate some memory in order to store the file when reading it. For that, we can use our platform allocate bytes function again, which we conveniently wrote last time. And yeah, then we just say, hey, I want, I'm not going to call it data again. I'm just going to call it, I'm just going to call it file. Doesn't really matter. So we're going to allocate as many bytes as the file count suggested. Then this function is the next critical one, which actually opens the file handle. So we're going to look at that again. So file, what it expects is again the file name. So again, the file path. Then the desired access. In our case, we use generic read because we're just intending to read from the file. And you can look at different access types here. The most common one is generic read or generic write, or you can do both. But we just want to read from the file. Then you have another flag which indicates whether or not you want exclusive access. In our case, we can just say share read, which means other applications can still open this file and read from it. And we can do too, because we do not want to lock it up for other applications, which makes sense, for instance, which basically if you don't need to do something else with the file, if you just want to open it once, then it makes sense to not prevent other applications from also accessing it. Then we have a null parameter, which is security attributes. We can ignore those. Then we have create disposition. In our case, oh yeah, so I'll just let me make this bigger so that you can see better. We have open existing is our, as you can see, the security thing can be null if we don't want any security stuff. And then we have this flag to indicate what will happen if the file does not exist, basically. And we will specify open existing, which means the file can only be opened if it already exists. Otherwise, you can also specify create always, which means if the file does not exist and you try to read it, you create this file immediately. But in our case, we want to read an existing file, so we expect it to fail if the file does not exist, which is also something that the get file attribute X will fail on if the file does not exist. So this is redundant in some way. But it's nice to specify your intent here. So this should fail if the file does not exist. So the other one is flag attributes. I don't think we need this at all. We should just use the normal one. Basically, oh, okay. It basically indicates how the file is stored on the system. So it might be archived or encrypted. So you have to provide this information too. But in our case, it's just a normal file without any different settings. So, okay, after that, we have the last field is template file. A valid handle to a template file. So basically, this is just some information that if you want to create something, you use another file as a template for its setup. But we don't use that. We just specify null again. So now we get a file handle, and hopefully this is valid. So I'm just going to assert on that for now. You could handle this error differently. So just going to assert that it's not an invalid file handle, like so. And now comes the fun part. We have, we should allocate this after we made sure that everything worked. So we could open the file, then we allocate some memory, and now we need to read the whole file. And the bad thing is that the function to read files can only support reading 4 GB at a time. So we have to loop and read multiple chunks out of it if it were bigger, but in our case, it's not going to be. But basically, we use the read file function, which needs the handle to the open file. Then it needs a buffer to where to store the data. So I'm gonna fix up this mess a little bit. So we have our byte count here, and we can say something like read byte count, for instance. And while we still have bytes to read, we continue. Typically, this will be just one iteration if your file is less than 4 gigabytes in size. And then we have a, just call it left byte count. And then we say read byte count is whatever. If our left byte count is bigger than 4 gigabytes, we will cap it to 4 gigabytes, how much we want to read. Otherwise, we will just read the remaining bytes that are left in the last chunk. So, yeah, this is all very redundant. Yeah, the naming is a bit weird. But basically, we specify the file handle, then we need to specify where the memory is. In our case, it's just file. Just gonna call it file data for now. Where to write. Then, oh yeah, maybe not quite. So let's just say, call it base, because this is also something that will be incremented since we have to read, for instance, 4 gigabytes. Then we have to advance where to read the next position. So I'm gonna create the base from this file data that we have to advance. So then we have byte count, which is basically this value, how much we want to read in this one session. So it's going to be probably most of the time it's just going to be 1 times we read the left byte count. So because our files are just not that big. This parameter tells us how much byte it actually was able to read. So for instance, it can be that you requested, you have a buffer that is bigger than what you wanted to read. It can tell you how much it actually read. So I'm just going to call this out byte count, for instance. And the last parameter is overlapped, which can be used to signal asynchronous reads, or if you want to specify where to read from the file directly, you can specify this overlapped struct and fill it out with the position in the file where you want the reading to happen. Otherwise, continuous reads will increment the file pointer in the back implementation of Windows and just start reading from the next valid location. So what we're going to do is assert that it's okay, and we will assert that however we wanted to read is however we did read. And then we're going to increment the base so that it can read from the next location. So basically, the base starts where our file data starts, and we increase where we want to read the file next, just by how much we already read in this iteration of this loop. And the same goes for left byte count. We have to decrease it about how many bytes we have read. And like so. And if everything worked fine, we can close the handle and just return the information about how much we read. And for that, I typically use a data type like a U8 array, which is quite similar to what we had with the sprite array, the string array, as you may recall. Where do I have it here? But basically, it's the same thing as the string array, so we can just rename this as to U8 array. But for purposes of intent, we can give it an alias like so. So that while the actual data is the same, so if it's just binary data with the size, it's the same thing as if it was a string, but the string type indicates what kind of meaning is attached to that data. In our case, that it's text information. So that I don't have to implement this type again, because it's basically the same type. And me. So, excuse me, so I don't need this thing, but I can just return a U8 array. And then we can also make a type of that. So let's just call this result. and then we can set result dot base to whatever allocate bytes returned, and result dot count to the byte count. This is the whole memory of the file. And then we can do, which is also neat, you can just set up an iterator and say the iterator is just the same size as the result. And then we're gonna continue reading from the file while there are still bytes left in the iterator. So, and then I can just rename this like so. And then we can just increment the iterator, and you can also make a function out of it, which is a common thing that I do personally. And then you can just return the result, which is the whole buffer, whereas the iterator is just a view inside into the whole buffer. So now we should have a function that can read an entire file from a given file path. So let's just try that out. So what was it here? Right, so as the demo implementation suggested, we can just try to read some file that should be installed in your Windows. Like for instance, consolas, I think, is always there. So let's just die Schrifteinstellung. Oh, Leute. Fonts. Console. Yeah, consolas should always be there, so you can click on it and then you see file name. And this should always be installed because it's a font that's is being used by your terminals, for instance. Consola. It's consola. F. Now we get the data, and then we can just see if that works. Clear out some errors. Oh yeah, we have dangling expressions here. And 2A2 says the base is part of the iterator. So, okay, we run it. Oh, we don't have a run if we call the main. Didn't crash, so probably it read the file properly. So let's just start Visual Studio to make sure that actually happened. Did I have a solution set up for this? No. As I mentioned the other day, you can just start Visual Studio by specifying where the exe is, and it will create a debug-only solution for you. So there is no source code or anything, but you can, as long as your exe that you provide has some debug information, you can step through it. So it takes a while because Visual Studio is slow, as always. Remember show caret, hide caret? So let's see. We look into the properties. Visual Studio is so slow. We can basically specify where these executables going to be started. I typically start it from the main directory, but it doesn't matter in this case because we have no relative files that we want to open. But if you had some files and the exe need to know where these are relative to the exe, you can specify the working directory here. Other than that, we're just gonna start, see if something happens. Visual Studio is so ready, you wouldn't believe it. So let's just see. Okay. We should be able to open a file. Or maybe I can just break. And then we see something, hopefully. Oh yeah, so as you can see, it found the source file. And we should be able to step through the code now. So that just verify whether or not our read entire file function worked. It's always good to test whatever you've implemented before you go to the next step. So let's just get here, start again, step into it, see what our get attributes file returned. So it told us that basically this indicates that our file is less than 4 GB big because the high 32 bits are not set. Computes the byte count, then it creates a file, or it tries to read the file, otherwise it would fail. And then we allocate some bytes, and we should have a valid pointer to some memory. And then we should be able to read in one iteration. So this should go to the second branch here, because we have less than 4 GB of data to read. Then it read this, and then it set the out byte count is 0. Why don't you trigger here? Assert okay, false. Why didn't this trigger? This is suspicious. Do we have some data? No, it doesn't seem like it. So if we look at the data, yeah, it's empty. Why didn't it read, and why didn't this trigger? Something wrong with my assert? Maybe. Let's see. That's why we do this testing, but typically this should just fail. So if I do something like assert 0, it should fail. So I'm not so sure. Maybe I did something wrong with the macro. We'll see. First we build it. The assert is not triggering at all. Is this not a debug build? What happened here? The file has been loaded outside. Why? Oh yeah, because I just added it in Visual Studio, which is a no-no. We should never use the Visual Studio editor to touch our files. Man, so basically, let's see what happens here. Oops, I don't need another window. We have debug information enabled, so this should work. That's our assert. Should implement this one. Otherwise, we can just verify error. Not this. Let's just see. Yeah, so it does not. Oh yeah, because it's underscore debug and not just debug. Yeah, did I do this mistake other places too? No, that's the only place I use, because this flag basically specifies this underscore debug macro definition. You can always add your own definitions if you do /d, and then without any space you can just add debug, for instance, and it will create a debug macro definition like so. So essentially, if you specify /d debug, you create the macro thing that I had previously. But we're gonna use the standard way, in which case we get rid of this. And now our macros, our assert should trigger, because the other times it just would default to replacing the asserts with nothing. And that's why we didn't get any triggers. So now we should get the assert. No. Yeah, let's just check it out again. Assert again 0. What the hell? Why is my macros not triggering? So just again. This is live, people. So build, and it should add this. Why doesn't it add this? I'm actually not quite sure, but as I demonstrated before, I'm just gonna add my own definition and see if that works. Otherwise, yeah, okay. Weird indeed. Not quite sure why that didn't work right now, but let's not dwell on that too much because it's not super important. So yeah, okay. So this, yeah, you see, I had a macro that should have been triggered already multiple times. So this one, weird. Let's just see. So this basically says that we cannot open the file that was specified. And as, of course, because our macro immediately returned, we cannot see what file path we have. So C, Windows, fonts, consola, TTF doesn't work. I thought it should, though. Can I please, the previous interface was so much better. Maybe it's just, maybe it is console-less and it just, the display is wrong. Wouldn't surprise me one bit. So let's console. How about that? I spelled it wrong. So it wasn't Windows for once. Cannot blame everything on Windows. Sometimes we do mistakes too. Oh, yes. You see now it says it's okay. It also says the file handle is correct. So now let's see if we can read the proper amount of byte. Oh yeah, we crashed, but it would have read the exact same amount. So let's just remove that assert. Oops. So let's see, assert 0, be gone. As you can see, it's always good to verify your assumptions, especially if you return to a project every once a week. So let's just see. It read, it said everything is fine. It increments everything. Now it should be 0. And now we can look at the data. And it just has some data that is not interpretable as a string. Or it starts with a 0, probably. So that's fine. Now we can get to the real meat of the thing and continue implementing the STB functionality. So now we can use STB init font with our new buffer. Here. So we read the buffer data. We have the data. It's just, we have the buffer. It's just a database, and then we can look at the info from init font to see what the last parameter is. And it says there is an offset, so we can basically specify if we have a file that would contain multiple font data, we could specify an offset on from where to read that file. But we know that we only have one file, so it's going to read this one data. Well, okay, that should be fine. It also returns something and returns 0 on failure, so we can just say auto OK and then assert that OK is not 0. Just see if our library does the thing. If you spell auto correctly, of course, as always. So now you can see that it complains that stb.tt init font is not implemented. And that's just because we only included the header in this manner. And this will only provide us with the actual header information like you're used to. But if you want the implementation, so basically the .cpp information, you have to specify this definition before including the header, like so. And you typically only need to do this in one of your compilation units. Every other place where you might want to use STB TrueType, you can leave this out. So it only needs to be in one place. But since we have a Unity build and basically only have one CPP file, this is the place where we should put it. You can also, if you're crazy, you can just do something like STB TrueType CPP and generate a file like this. And then you have this separate translation unit if this is your style. But we don't do that here, so I'm gonna kill it with fire again. So now, since we also want to include the implementation, we should no longer get this missing reference warning, error to be more precise. And then you have the problem that STB TrueType also has an implementation for assert, and it says that we are basically defining assert twice. So there's also why is this open like this? Do I have this editor open twice? Probably, yeah. I had my editor open twice, so whenever I did changes in one instance, it would think that the file has changed outside. So okay. So basically, if you want to get rid of assert, or if you want to tell STB TrueType you already have an assert and it should use that, you can look for assert and maybe small, and you have something like if not defined STB assert, it will define it with the default assert. So we can just take this, and before loading the header, you can say, hey, by the way, STBTT assert is just our assert. Trust me on this one. So also you should define it in the same manner, so it expects one parameter. So this is what it expects, and now it should just use our internal assert, which is also a nice feature. Also, it complains now that the assert is defined later, so we can just move this down. Basically, this is some internal library code that you want to reuse anyways, and typically after that you would include your more specialized functions. I'm not worrying about structuring this program at all right now, because it's just a simple thing. I mean, right now it's like how many lines of code? 500. It's not a lot to organize, but if you feel like, if you're confused by it, you should definitely consider spreading out these functions into different files. Then it also complains that its assert is used differently, because basically it expects this whole thing to be callable in one line. In order to support that, we need to add a local scope around our assert. So now that you can do something like if x assert, otherwise it would have added an if here, and that might clash with the scoping. So if you have one line, things, it's always a bad idea to call macros. In my opinion, it's always a bad idea to call macros without surrounding scope if you have a one-line statement. It still complains. We can look at where it complains. Was it correct? .3064. So it says assert. It has this one. Why do I have this? This is just annoying. Who did this to me? Windows. So as you can see, yeah, it's a bit ugly. So yeah, but it's a good thing that we do this. So now we can do something like, hey, you know what? We're gonna use void assert STB assert wrapper, and just pass in an int, and it's just gonna call our assert now. Hopefully this works. And then we use the assert wrapper instead. And this should be callable in a line like this. You can imagine that if we use the macro that we had, because it's literally copy pasting it, it would look something like this. So let's just see. You have if x, and then you say assert, and then maybe you say else, ... That would be copy pasted to if x, and then if assert x, for instance, and then scope ... Then it would place this semicolon as here, and then it would do the else branch. But this is syntactically incorrect. So it can do two ifs, and then also afterwards, if we would leave out the semicolon, the else branch would attach to this inner assert if, which is also not what we want. So I'm going to wrap this basically into a function call so that you can use it like so. Bit ugly, and I really don't like that he did it this way, because it makes assert macros quite hard to use. So this way I'm just going to wrap it around a function so that it should be syntactically correct. So yeah, but just so you know. But it's good that we ran into that problem. Okay, that worked. So, well, did it though? We'll just do assert. So it didn't assert, so it means it could init the file just as expected. So let's just get back into the implementation part and try to read the information. We're already 47 minutes in, so I would say that's quite slow, but hey, we didn't have a lot of functionality that we had to include before we can go to the meat of it. So let's just see. We have opened the file properly. We have init our font data, and now we can specify a pixel size that we care about. So let's just do that. So this all went well. And then we can say, hey, please scale the font in such a manner, or give me the scale that would result in a 16 pixel height rasterization. And then you have the send. I'm not sure if I need this, but honestly, because I always find it hard to reason about this, I rather consult my own implementation, since I thought through this problem, and I can now help myself basically with how to interpret this data. So I have this load font function here, and we're at the same location here. I read the file and I initialized the font. We can do this like so. So the steps are more apparent, and we specify the scale, and then we get the ascent and descent, and basically this is what I came up with, what the line spacing should be, and I trust myself on this. I don't know if I ever used the baseline. As you can see, I didn't, even though I copied it from the example. So I'm just going to do whatever I felt right at the time. So you have these values, and then you can compute how much you have to advance from one line to another. But these values are basically in the units of the font definitions, so you have to apply the scale still. This is also something that if you look up the functionality, the documentation will tell you about. So if I were to search for this, the first occurrence maybe. Ascent is in coordinate above the baseline from top, whatever. These are expected in unscaled coordinates, so you must multiply them by scale. So that's very good information. That's all we need to do the proper thing. So since I don't have a font definition yet, I'm just gonna use an int, and then we're gonna slowly go to the next step, which is basically loading glyph information and trying to create a texture from that. So let's see. First, we want to iterate over our glyphs. So for that, we can just specify an array like a loop like this. We start with the space operator, with the space glyph, and we end by we want to have the first 127 characters And these are basically the ASCII characters and without any extras. So I can just iterate over these characters. I can call it C or code. They are typically referred to as code points, so we can also call this code point. These are expected to be UTF-32 and code points. So basically, if these code points are in the space that supports all known glyphs and characters from all the human languages, so defined in the UTF-32 standards. But for the first 127 or so, these line up with the ASCII symbols. So we're just going to use these because also we do not support UTF-32 with when reading from the Windows the Windows input right now. But we might address that in a later tutorial. So basically, all we need to do is when iterating over these, we have to call this function here. Yeah, that sounds good. So we call this function here, which, as the name suggests, will return us a... does the name suggest? No, it just will return us the bounding box of the specified character. And then we can do some computation on where to place it. And then this call here will generate will fill out the pixel information, rasterize it for us into a buffer that we specify. So we're just going to do this for one character first so that we see that everything works. So we're just going to say, do it for A and stop at B so that we can see something happening at all. And in order to do that, we should have a texture which holds this glyph information. So we will create a texture first, like we did with the frame buffer, like this. Just going to call this font atlas. Use our make frame buffer function, which just specifies a width and a height and then allocates a pixel buffer for this. In our case, we probably don't need more than 512 by 512. Then we have this texture, and then we can fill it with information. For instance, we can just say, hey, let me think about this, because this function will generate only alpha values, so it will not generate color values. It will only give us the alpha channel, but our data is expected to have RGBA values. So we cannot write this immediately. We need some intermediate buffer, which only has the alpha values. And then we have to translate that into RGB colors, if we care. So in order to do so, I'm just going to create a simple buffer. Just going to use our just going to use a buffer. Just going to call it array glyph buffer. And I'm just going to say, hey, assuming one individual glyph is not too big, you can just set a count, which is let's just say 64 by 64 is probably all we need for one individual glyph, given our pixel height that we specified here. We should give it a name so that this 15 now becomes more tangible value. So like so. It's always good to have do not have naked constants without a context. If you are unsure what it is after reading it again, it's probably a good idea to give it a name. And this is basically free, so it's not like you're wasting space or anything. This will get optimized away if you only specify it once and then you only read it once, but also if you really want to do that, you can also make it const. But I personally just rely on the on the compiler to do this for me. So now we specify some size that is enough to hold any particular glyph, which should fit into a 16 by 16 pixel height. And then we allocate some memory for that with our fancy platform allocate. And we just say how many bytes we want. And this will give us more because typically, well, we can't access more because we didn't record it. But typically in the background, you always get multiple of 4 kilobytes because that's the page size Windows allocates in the background. So it's quite wasteful to call this with very few memory. But this is just an intermediary buffer that we use for STB TrueType to fill out the information, and then this will go away later. So we use this for all the glyphs basically. So we can just use our glyph buffer here and fill it up here. It's basically just for test purposes. We get the width and we should get the height, which I haven't recorded. Yeah, it's like this. So get the width and the height. So I still call this font. I still call this font info. I should read this. Like so. Yeah, so okay. Then we should be able to fill out this information. And if you look at, if we want to look at these functions, we can look at the implementation in the documentation from STB image, and then it will explain us what the parameters mean. How about a better version? Yeah, okay. So this information is not as accurate, but it refers to the same as code point bitmap box, so we will find the same parameters here. So basically just will return us some rectangle which specify on one hand how big this glyph is, and on the other hand how to place it. So basically if we look some documentation about how glyph rendering is supposed to happen, FreeType is also a very good library, and it also has some good implementations, but it's a little harder to set up because you basically are required to precompile it and then link against the library. In our case, we just had to download the STB-H, and then we can just use it without any problems. And here we also will find tutorials on how to use FreeType, but also it helps us with some information on what glyph data we actually read. So let's see. There was a good documentation. There was basically a good picture that explains a lot of this information. Glyph metrics, maybe it's that one. Yeah, here. So glyph metrics, that's the one. So I could link it into the chat, maybe. Can I? For all that are curious, because it was a little harder to find. Basically, you can see the width and the height of a glyph is also what we get from STB TrueType. What we also get is basically, if you consider this line here, it's called the baseline. Basically, if you had a piece of paper and you were to write on it, typically you get lines on where to place your characters. And this is the baseline. And you can see that there is a value in X and Y, which indicates how much down or to the left of the current baseline position. Like here, the bearing X is, consider this is where you need to draw your next glyph. The bearing X tells you how much your character should be displaced or offset to the X position of your current cursor position. And the bearing Y tells you how much it is displaced, how much the top is displaced from this line. In this case, FreeType assumes that you render basically from top to bottom. That's why it's in this coordinate system. Our coordinate system is flipped. So basically our lowest point or our lowest value is here in Y direction, and Y grows up. But typically fonts or UI systems are handled top to bottom, so the values of the Y dimension increase from top to bottom. But in our case, we go from bottom to top, so we have to consider this too. And this is also the case for many of rendering APIs like OpenGL, even though you can flip this around in many ways, like when you create a camera or when you specify a shader. But this is basically the information we get. We get this x min and x max, and we get this y min and this y max, and they're all relative to wherever the cursor is, or the baseline. So, but you can just calculate the width and the height by subtracting the x1 from the x0 and the y1 from the y0. And this should fill out the proper glyph information here. And also you have to consider you're passing down the scale in x and y, which is what we ask for. Given a specific pixel height, how much do I have to scale this unscaled coordinates that the API is providing us? So, and you do basically, as you can see, you have the same settings twice here. So if you ask for the bounding region, you should use the same value to fill the pixel buffer. So we get one thing, and then what we want to do is basically place this thing into our font atlas. So let's just do that. And for that, we're just gonna go over the width and the height. So starting by 0 and going to height. So, and we want to copy this information, which is basically just the alpha channel. So you get 1 alpha value per pixel, so 8 bytes per pixel, into our frame buffer, which expects 4 bytes per pixel because it expects red, green, blue, and alpha channel. So all we need to do is get our font atlas, get the base position of that, then y times the font atlas width, and yep, plus x, and we just gonna specify RGBA a color, and the color is just gonna be whatever the value of the glyph buffer is at that position. So we just say y times, this times it's the width, this times it's the width, because this is how far each line is separated in the pixel buffer that we specified here, plus x. And then we just replicate this value to the other channels. R, G, E, and A. And then we can set this color to our font atlas. And now we want to see if anything is actually written into the font atlas. And for that, we can use our function that we wrote last time, the blit function. So basically, all we want to do is blit our font atlas at a specified position. Let's just say 0, 0, or 10, 10. Maybe we see it better this way. And then we specify which other buffer to blit into the sub buffer, which is just our font atlas. And then we have to specify which sub-region of our font atlas we want to blit. In this case, we just want the whole damn thing, because we would just want to use this for testing purposes. Like so. And if that works, man, it's never gonna work. I mean, of course, after the errors. So what's this? F32 is undefined. Come on, bro. How can you do this to me? Let's define it. And again, feel free to skip this step if you like. F32 is just float. Then we get to the next serious error, which is platform allocate is spelled wrong. And then we have more spelling problems, probably just syntax. Oh, as you can see, I renamed the iterator to code point, but I didn't change this. Also, I didn't change. Oh yeah, no, it's used the code point here, so that's fine. Okay. What else do we have here? Font doesn't like font width, which is fine by me. It shouldn't use it anyway. Does not take 9 arguments now. That's a concerning error. Let's just see again. So we have the code point. No, that's not the one. Which one is it? Makes up. Always handy to have the documentation. This one. So we have the output char where to write the data. Then we have the width and height of the output buffer. This is bad naming in my book because it suggests that's an output value, but it's just the out value of the output, the width value of the output that we specify. It's weird. So then we have to specify a stride. Okay, that's just basically the width again. Makes sense. So the stride basically indicates, if we open Paint, maybe you get a better understanding for that. So let's just open Paint, because why not? So let's say you have this whole texture atlas, and you want to fill in a subregion of it, which is basically what we can do with this function. We can tell STB TrueType, I want you to place your glyph data inside this rectangle here. And right now we only specify the width and the height, right? But we also specify the width twice. So what's the deal with that? Well, the deal with that is basically, if we were to subdivide this buffer, is just assume this is a 4 by 4 pixel buffer or subregion. Let's just say that. And in our case, we start here at the bottom. So we start here at the bottom, and we want to specify xy coordinates. So let's say we want to get to this point here. Oh my God, how hard can it be, please? I want to just do a cross. Oh my God, so let's make this big, and that's okay. So this is what I want to specify, this coordinate. So you would assume that all you have to do is multiply the row by the width. So in our case, it's this row here. So it's 0, the first row. So it's 1 times, let's just write it down. So it's 1 times the width plus 3, plus 2, basically. So it's 0, 1, 2, and 0, 1. That's a row. So that's what you would assume to calculate to get to this position in the subregion. But that's not correct at all, because if you consider the whole thing, since we are only looking at a subregion of this whole frame buffer, the advancement from this cell to this cell here is the whole width of the original frame buffer. So it's the whole width here. This is how much you want to advance from one row to another, because this is how these cells are laid out in memory. If you were otherwise to specify this, all you would do is basically advance. Oops. Let's just use the copy tool. So basically what you would do is you would advance. Oops. Oh my God. You would advance so, and you will end up with, let's use this one. You would end up in this position here, because this is how the memory is laid out. So this value of how to advance from one row to the other is typically called pitch, and that's why we have to specify it separately, because it can be the case that we have a bigger atlas and we want to specify a subregion to fill in, but we also need to specify how much to advance in this bigger atlas from one row to another. I hope that makes sense. And that's why we, since we only use one complete textures, our glyph buffer, we have to specify the width twice, since we are not using some subregion of another buffer, basically. Also, you see it here, I have to multiply with a different value depending on what buffer I'm using. So let's see if that makes sense. Okay. Oh yeah, here we see we have an A. We have a little A. And that's awesome. So it rasterized the A for us. So that's already great success. In order to make this a little more visible, we're going to use something that we implemented last time, which is basically we allowed our present function to specify the width, the window width and the window height. And we could have a smaller frame buffer that will be stretched to the full width and height. So we can do that too here. So we can do something like we take the width and the height, and all we do is basically we divide by some zoom factor, or let's just call it, yeah, just call it zoom. I'm just gonna take 8 times zoom, for instance. And if we divide the width and the height of the frame buffer by the zoom, we get less pixels, and these less pixels will be then stretched out to the whole region. And this way we maybe be able to better inspect the contents of our buffers. This is also MTX asked in one stream whether or not RenderDoc supports software rendering. This is the reason why it doesn't have to support software rendering, because we can look at any intermediate data ourselves, since we have the full access to everything. So we can build up our own tools. The only reason why we want to use something like RenderDoc is because a lot of things are just inaccessible to us. That's going on in the GPU. So I have the zoom factor now. Let's build and run it again. And now you can see the A is a little bit bigger, but maybe it's still too small for you guys. So I'm just gonna make it even bigger, if that's a word. It's not. So now you see the A. And one thing you already notice is that it's upside down. This is because the coordinate system of STB TrueType expects things to grow in memory from top to bottom, but we defined everything the other way around. So the first thing we want to do is when converting the glyph data, the RGB, the alpha channel to RGBA, we can also flip the position. So basically, instead of using this Y position here, we can just flip where we want to store it. So we can just say whatever the height is minus the Y. So, or better, height minus 1 minus Y. This will flip the coordinates for the target buffer. So it won't flip the coordinates for the source buffer, but it will flip where we place them. So we will swap the lines around, basically. Oops, I haven't compiled. Hey, our A stands perfectly. Wow. Okay, cool. Now we want to add more stuff than just an A. And in order to do so, we have to reconsider this algorithm a little bit, because right now, if I just say, hey, let's just also go from A to Z, for instance, what will happen is basically we will overwrite the same location in our source frame buffer here all the time, since we are not changing where to draw the buffer. And now we'll end up with whatever last letter we have, plus some overdraw from previous letters. So we end up with Y because we go to Z excluding Z, but we also see some portion of previous writes, which is not what we want at all. So now we need to, whenever we add a new glyph, we also need to make space for another glyph. So we need to advance where to write it into our frame buffer. So in order to do so, we will introduce some new variables. Basically, I'm just going to call this X offset and Y offset. And for now, I'm just going to add them here as if we would have calculated them properly. So it just tells you where in the destination to write this data when we copy. This way around, we can actually add the Y offset. Yeah, makes sense. So if we do that, and now if we, for instance, after every character, we just increment our X offset by, let's say, 20, we should have the characters written in. Of course, this can crash if the buffer is too small, so this is just for testing purposes. So now we see we have placed the characters and spaced them. Why is this not scaling properly, my friend? This is not good, so let's fix that. What I wanted to do is have the zoom. Zoom is, oh, yeah, that's stupid. I have to divide the window by this, not the frame buffer. Yeah, that makes sense. Okay, so basically I divide whatever resolution I get, but this subframe buffer width and height is still the maximum that we get after copying from the original frame buffer, so we should not go over this maximum size that we allocated, which if you if you can remember was 2K by 2K here when we created this frame buffer. Oops, yeah. Still, I should. How about this? I'm just gonna do both of those things and see if this works. So okay. Now you can see that the 32 was a bit too much. I was wondering why I had to specify such a high value, but I didn't think too much about it. So now let's just go to 8, for instance. Build main. Now that looks way better. And now you can see, oh yeah, we have our other stuff going on too. Now you can see this is the content of the buffer now. And as you can see, there's a lot of space in between those, and we don't really care for that. So it's quite wasteful. So also we know how big each character is. So we should advance this properly by the right amount, which is just instead of just having an arbitrary amount after filling one character, we can advance by whatever the width was that we have that was returned to us. Also, we can increment by width +1 if you want some spacing between characters, which is nice if you are using a 3D API, because otherwise you get some artifacts with borders. In our case, it's not really a problem because we could pack this more tightly because we're doing software rendering and essentially just hard copying subregions without any interpolation. So this didn't compile because width is wrong. And now you can see these are packed quite tightly with 1 pixel border after each one. But now the thing is, now the problem is that maybe this is after the advancement, maybe we will reach the end of the width, and we should advance in the y direction instead. So in order to do so, I will just check basically. Instead of incrementing it right here, I will check whether or not our X offset plus the width, whether or not that is plus the width +1 is bigger. Let me think about it. Is bigger than whatever our atlas supports, which is basically the font atlas width. So if that's the case, we need to go advance in the y direction by some value that we don't know what it is. And we have to reset our X offset basically to start at the beginning of the row again. So we just set 0, otherwise we just increment the X offset again. And why am I saying we don't know what it is? Because it doesn't matter to advance by our personal, if I run the main again, it doesn't matter to advance but with whatever height we have right now, because it might be the case that, say, the H wouldn't fit into the row, and we would advance by the height of H, we would end up somewhere where we would overwrite the G letter later on, because G is higher than H, or J is higher than H. So we need to make sure that we advance to the next line by whatever the tallest character was. So we will keep track of that too. So let's just see y max height, or this y max height. This is the max height on this current y position, basically. Just gonna set it to 0. And I'm just gonna say it's whatever the maximum is from this and the current height of the character. And we're gonna increment the y by this value, and then we're gonna reset this value also for the next row. So that should be it, and we should assert that our y offset is less than our font atlas width. Otherwise, y offset plus height basically is less than our height. Otherwise, we would go too far in the texture, and in this case, we would just increase our atlas size. This is just a sanity check. So let's see if we can fill out more characters this way. First off, let's see if this still works. This works. So we haven't written enough characters to go to the next line. And I don't know. Oh yeah, we increment the x offset before writing something to it, which is not good. So this needs to be done after we copied it anyways. This. So we always increment the x offset, but we test before we go to the next line. So this time, if we're here, we made sure that this worked properly. But if you want a sanity check, which is always nice, you can just check whether or not the x offset is actually still in bounds. Something like this. And it is actually allowed to be this, I think. Okay, so let's see. Yeah. Now we properly align with the beginning of the texture atlas again. And also, we can also give it a border. 1 pixel border while we're at it. But actually that's not necessary either way, so let's just ignore that. So now we can do the initial implementation where we go from space to all the visible characters. And let's just see how the buffer turns out. Look at this. This looks nice if you ask me. So because we don't see enough, I'm gonna reduce the zoom so that we can look at the whole thing. So now we should see the end of the thing. It's still a bit too big, so let's reduce the zoom further. So yeah, so now you see that the what's it called, character wouldn't have fit here, so it was moved to the next line. And you'll also see that for this limited character set, we don't need that giant texture, so we can be a little bit more conservative if we like. So we just can say, hey, let's just say either we can also increase the font size for I'll just say it's 20. See how this works out. Already way better to read, but we'll still have plenty of room, so maybe we just have the or quarter the size of our font atlas. Yeah, still plenty of room. Still plenty of room for all kinds of glyphs. So, okay, now we have this information, and now the next step would be to actually use this information to render text. So I would already say this is a success for now, and that's also the beauty of software rendering, that you can just inspect whatever you did without any external tools. So that's great. And now, in order to to place those characters properly, I already explained to you that this x1, x0, y1, y0 metrics are for placing also, not just to determine how big a character is. So if you recall, so we need to remember this bearing x and bearing y here in order to place those characters properly so that they have good distance to each other. Also, they have this extra metric that we haven't looked into it, which tells us if the cursor, basically the position that we're going to write the next glyph, how far do we have to advance that in x direction for the next character to be placed in. It's also a glyph dependent metric, so it can be different for every glyph. But if you are using a monospace glyph, it will be constant, for instance. So we need somehow a way to store this information, and that's why I'm gonna create a buffer, a new system for. How about this, people? How about a little compromise? I'm gonna add a new file. You wouldn't believe it, but in order to do so, I need to add even more files. Okay. Let's add some files. I'm just gonna add a basic file which contains some information about this commonly used things. That's not the one. Where's my main? There's my main. So the commonly used things are these, for instance. All the things that I want to use in multiple projects, for instance, that are just basic functionality that I always want to have, and I just want to move them somewhere. So, like for instance, I'm just gonna move the platform stuff. Platform stuff? Nah, not the platform stuff. That would belong to another file. So basically, just the basic information, and I don't know why this is moving so much. Oh, I pasted it in the wrong place. Oh wow. Great job. Great job. Where did I paste it in? Oh, Where did I paste this in? No. No. I didn't paste it anywhere. But where is it? That's a nice thing about having undo. So, okay. So now this information can go away. And instead of having this, we're just gonna this is also here. Yeah, no, it's already here. I'm gonna specify pragma once so that this file is not going to be loaded in multiple times, and then I'm just gonna say, hey, include my basic file where my common data types and simple functionalities are. Let's just see if this works still. Always nice to see if your stuff works. So yeah, okay, that works. And now I can create a common font file. I'm gonna call it font.h. I'm gonna pragma once again so that it's not being loaded multiple times. And this file needs the basic file stuff. So for this, I'm gonna use all the STB stuff. I'm gonna put it in here. Make the code a little cleaner, just a little, not too much. This stuff arguably is also part of the font stuff, but let's just not do that right now. What is part of the font stuff too is our way to create a font buffer and stuff like this. So that's why I did this. So I'm just gonna create a thing called font glyph, which contains information that we need on a per glyph basis. Essentially, which is something like X offset, Y offset, X advance, and we also want a region into our frame buffer where the glyph is located. So just gonna tell the X, Y, and width height. So. And we will generate this data as we go and iterate over our glyph points. And where do I have stuff? This is the font atlas stuff, right? So all this beautiful code, I'm gonna put it here and say make font. Make fonts, not war. So I hope the stream is fine so far. Not a lot of chatting going on, I see. Or is this frozen? I'm not sure. So basically we want to create this font thing. So just calling it font is a little bit dumb because I want to use this as a name probably. And I'm kind of always using everything in lowercase because it makes it easier for macros to change types. If it's spelled differently, macros cannot cast to lowercase or uppercase or anything. So I typically try to keep everything lowercase so that it works better with the macro stuff. But you can also feel free to ignore this. Also, I heard from people who just start programming that it's hard for them to reason about things if one thing is called font with an uppercase letter and another thing is called font with a lowercase letter. In their mind, there is no distinction between those two things. But we're not really catering to beginners, but still, on the other hand, I want to help beginners to get into this API. So yeah. So our make font function needs a file path. This is this one. So here we just say, hey, please make me a font. Call it font. And I'm gonna call this, I'm just gonna call this loaded font because why not? Because it suggests that it's some kind of asset. And part of the font will be a frame buffer, which is also a good place now to separate stuff. I'm just gonna call it SR for software renderer, or just call it render.h. Yeah, render. Render is good. So now you see, once you start placing things in other libraries, you now have to organize a lot of other things, which is not a bad thing, but you know, you have to do the work. And for this, I also only need the basic.h, and I will specify all this rendering related stuff in there, like our RGB struct, our create frame buffer struct, fillbox and split function, and present function is Windows dependent. Yeah, that's also horrible. Because this also means now I need to include some kind of platform file. Horrible, horrible. But hey, why not? Doesn't hurt. It makes everything maybe a little more organized. So for that I use all this stuff. And platform character. And the callback, and allocate bytes, and read entire file. All that beautiful stuff as part of our minimalistic platform code. And now our font code can use this platform code. Not the font code, I mean the render code, because the renderer wants to use the Windows-specific ways to deal with all this stuff. Let's see if this still works. Yeah, I thought so. Let's see, build more to see what the first error is. Main 11. Yeah, stupid me. I didn't include all the stuff that we're using right now, so. I need platform, I need font. I mean, I don't need to include all of them, but it doesn't hurt also. I don't want to think about the dependencies, so I can just include all that I need. Now if we go to the font age, we'll see, we were about to add frame buffer. Just gonna call this atlas. And loaded font is what we return. It's gonna call font, initialize it to 0. Then we have all this stuff. It's a beautiful piece of work. So here, remove one of this, return our font if everything went well. We set our atlas to the font atlas. And slowly but surely fix this problem. So what don't you like about SR frame buffer? Atlas unknown override specifier. Yeah, I haven't used it here, so yeah, that makes sense. That's just called render. So now go 31. What don't you like about Atlas? What's wrong with my render? SR frame buffer, perfectly well defined. Yeah, of course, I spelled it like this, so that's my bad. Font 40. We read the entire file with the file path. Also, as you can see, we require the platform file here too. Lots of dependencies, but the renderer already had dependency to that, but I like it this way. Atlasy. So now 107. You don't like me to return the font. Is it void? Yeah, I thought I changed this, but I didn't. So now we go to the main and to prop position. Why? What? Oh, it's called render, not renderer. Yeah. So now we have this, and we did this, we should make font, right? So now we have to, instead of using the font atlas to blit, we have to use font.atlas because the atlas is now part of our font definition. So also we have to specify the font atlas frame buffer. And now we should be back to feature parity. Yeah, awesome. Awesome, awesome. So now we can further put some more details into our font. Basically, we want to support a fixed amount of fonts, like so, a fixed amount of glyphs. I'm just gonna say, hey, how about we support 128 glyphs? Just what we have right now. We have less than that. We also want to make sure that we specify how many of these we are actually using. You can of course always do this dynamically, but this is just for the purposes of editing, not necessarily for the purposes of dynamically allocating files and stuff. So yeah, we have the glyph count, which gives us all this information. We also want something like line advance, for instance, if we want to support writing to multiple lines, which is just typical. We have the atlas, we have this. All this information is probably all we need. So we have all this information, and now we can just fill it out here after we gather the data. Font, line, advance is just line. I called it line spacing, but I'm gonna rename it. I called it line spacing here somewhere, right? So, and now I want to do this stuff here. So, and for that, I just gonna, after we get all the information, here is probably all we need is here. We're just gonna say auto get me the next glyph in our font glyphs. Font glyph count, like so. Get me the next glyph, and let me fill out the information. right now, for instance, we want to know where to place the glyph. This is basically, did I give it a proper name? I probably didn't. I give this a name. I'm just gonna call this box or atlas box. Maybe that's a good name. Atlas box. It doesn't hurt to be extra specific. So the atlas box is where the X offset is currently. That same goes for the Y offset. Basically, wherever we wrote it, that's what we want to also remember in order to reproduce that character at the proper location. Width is just the width that we got from STB. True type. Height is also the height. Now there are some metrics that we don't have. And I don't know if we get them here, so I'm gonna consult my own implementation because yeah, I think that worked quite well. So as you can see, I have similar data, just a little less information. Oh yeah, so we also want the X offset of the glyph, basically, which tells us how to place the glyph texture relatively to where our current writing position is. And it's just basically whatever the x0 value is. So the x0 basically tells us how far we are from the writing position. This is what we get, this distance here. So it's just x0. And then we have the y offset. And it's negative y0 because it's it's negative y1 actually, because STB true type has the y coordinates flipped. So what we would get is basically y1 is down here. So since it goes from 0 to 1 from top to bottom, it's different than what this glyph this diagram suggests. Here would be x0, and here would be y0, and here would be y1. And as you can see, this value would be positive because it tells you, if this is the baseline, how much further down the y1 would be, and it grows from top to bottom. So this value would be positive but in our case, since we want things to go from bottom to top, we need to negate this value so that we can place our character down in negative y direction basically. And then also what I need is the glyph advance, x advance, and that needs a special needs a special call, if I recall correctly. Where did I specify this? Yeah, here. We need an extra function which is called get code point metrics, and yeah, and then we get the advance like so. And I also did some kerning stuff, but we don't need to do this right now. So probably all we need is another call here to get the advance. And for that, we just specify the code point. And we will get returned the x advance and something else that we don't care for. And we can, as always, just look up the documentation of STB. Oops, my awesome editor crashed on me. Happens sometimes. So if we look at what this is supposed to bring us back is left side bearing and the advanced width. And I don't really know what the left side bearing, it's the offset from the current horizontal position to the left edge of the character. The current horizontal position to the left edge of the character sounds pretty much like this bearing here to me, which is probably also what the X should have given us, but maybe I'm wrong. Maybe this is the one we should use instead of the X offset. But it did look properly in my case, so keep that in mind. So this might be, I'm just going to comment it because I haven't tested it. So this is maybe the X offset. Maybe X offset. And I'm gonna comment on this. So that's always nice to have. And now, as with many of these things, these are in unscaled coordinates. So what kind of value do we get? We get ints. So we need to also apply the scale. So this is x advanced times the scale, which we got depending on our pixel height that we asked for, like here. So now we should have all the information necessary, and we should fill out all this data probably. See if this works. Glyph count is not a thing, it says. Isn't it? Glyph count, yeah. Almost. So now we have this information, and now we have all the information that we need to actually print this properly. Bear with me, people. We're almost there. Oh boy. So let's just see if this still works. By the way, I need to take a small break. I'll be right back. Staying hydrated has its downsides. How's chat doing? Very focused, I see. No off-topic chatter. Or you're all sleeping. I don't know. But I don't care. I'm gonna just continue. So let's see. Now we have all the information, and we want to actually render this mass. And in order to do so, yeah, that should be good. So now we're just going to introduce a function just called write. All right. Then we give it a frame buffer, frame bugger. give it some position where we want to write to. Give it our font. Well, I will move it here. And then we want to give it some text. So just a little C string maybe. Text. And what it should do is basically go over the text, pick up the proper glyph, place it at the right location, and then advance our X and Y position. So in order to do so, we just just do a little while loop and just say while text. So we assume that yeah, well, we can just always assert, we can just always make sure that if text is null, we just return and we have nothing to do. Maybe that's reasonable. Otherwise, as long as we have some text, as long as we do not hit the null termination character, we will figure out the code point, which is basically just whatever the text at the position 0 is. Then we need to get the glyphs index somehow. Let's just assume we have this, and then we just basically gonna call our lovely function blit, like so. So we're just gonna say, hey, blit me into this frame buffer, blit me at the position X and Y, whatever the font atlas is, and whatever the font glyph at that position is, like so. We get the glyph, we use the glyph atlas box X, atlas box Y, atlas box width, and atlas box height. So we just want to blit essentially copy the subregion where the glyph is stored in the atlas into our frame buffer. And then we want to advance the text, and also we need to advance our X, for instance. We just say X plus is whatever the glyph X advances. So, and that's all we do, and this should fill out the information properly. And I'm just gonna write in the usage first. So we used to test, oops. Oh my god, you see my editor is a little broken. I don't know why. Honestly, I haven't gone around fixing it. Probably some simple mistakes, but you know, works well enough. It reboots quickly enough, so I don't really care right now. There's a lot of other things to do. Let's comment this out, and then I'm just gonna say something right to our subframe buffer at some position, like, I don't know, 20 and whatever the subframe buffer height is, -20, which is basically the top of our frame buffer in our coordinate system. Then we specify our font, and then we want to specify a text like "Hello World," finally. Something like this. Just test. It's not going to compile right now. Yeah, it's okay. So back to the font. No, Windows, please. Okay, thank you. So now the crucial part in our algorithm is to get the glyph index. And we are gonna do the dumbest thing possible. Okay, cool. We have response from chat. That's great. Glad you guys are watching at least a little bit. So I'm just gonna do the dumbest thing possible. I'm just gonna linearly iterate over our glyphs and pick the matching glyph, if there is any. typically you could do a little bit more smarter thing. Basically, just well, you could sort the glyphs you have by the code bind and then do binary search. But we don't really have to sort since we inserted them in a proper order, but just for future reference. And then I could still implement a binary search to figure out the proper glyph, but I just don't care right now. I'll still do this later on. So what I'm going to do is say the glyph index is -1, and then just going to iterate over all the glyphs in my font. Maybe while also comparing the iterating variable, just maybe. And then we just gonna say if font glyphs at the position I. Oh yeah, see my friends, I also forgot to add the code point. I'm just gonna call it UTF-32 code point. Be extra sure what it is. And we should fill out this information. It might come in handy if you have glyph data which is not contiguous. I'm just gonna call it code point. Oh my god, I have such inconsistent spelling. Not even funny. In English, I'm never sure how to separate those words. In German, you could all write them one giant word. It would always work, but it's harder to read. So we check if the code point matches code point in the text. If so, we say glyph index is I, and we break this loop. And then we can say, okay, if our glyph index is not -1, we can do the rendering part and the advanced part. Otherwise, we're just gonna advance the text, but we could also later on render a missing glyph, for instance, which we also already have in our, if you look closely, it has generated a missing glyph symbol for our last character. So for the 127th value, it generated a missing glyph symbol because that's not a proper Unicode character, or it's not in the font. I think it's not a proper Unicode character though. So we could use that one to render missing glyphs. So if I'm sure this is the case, I can just use that instead, but maybe I do this later. So let's just see. So if we have a proper glyph index, like so, we render that and then we advance. So now we're so close, people. So what don't you like about this? It's heights, of course. 250. Cannot convert int to loaded font. Yeah, maybe you shouldn't. Oh yeah, because I wanted to specify the font right after the buffer. Okay. The moment of truth, everybody. Oh, look at this. Look at this beautiful hello world. It's awesome. It's amazing. It's the best thing I've ever seen. Oh my god. We're completely ignoring the alpha values right now, but that is fine. We can still do that later on. But now we have rendering text capabilities again, and we should be able to render not just this text, but the text that we used to have before in our test buffer. Not test buffer, but we are still filling out our text with the input we get from Windows, so we should be able to actually just print that. And yeah, we should do that like so, but we should also, instead of using the plain C strings, we should now specify our strings, which have a length. So instead of using text, instead of checking for null termination, we can now check the text count, like so, and just get the base character here. And when we advance, we have to advance the base and we have to reduce the count. Like so, for instance. You could also increment in some int that instead of specifying 0, you can have something like a character count or whatever. But this way, it makes more sense if we want to switch to UTF-8 support, because in that case, this string data can have one character encoded into multiple bytes, so you would advance by a different amount of bytes after reading one character. So let's just see if this works. Binary, Oh yeah, so we don't need that at all, because now whether or not text is null or not doesn't matter, because the count should also be a 0 if the base is null. Hello world. Wow, it worked. Almost. Wow, something is a bit wrong, but maybe the deletion is wrong. The world. Space doesn't do the proper thing. Something is wrong with the deletion. But as you can see, we are almost there. We'll almost have the same functionality, other than it looking ugly. But you know, that's something that we have control over and that we can improve upon. So let's first implement new lines, because that's something that we didn't take care of here. So if we have a new line symbol, this whole stuff is not necessary. Instead, we can just do something like if code point equals the new line character. What we want to do is advance the Y position by whatever the font line advances. And we want to reset the X position to the start X, or line X. Let's just call it line X. We don't have this right now, but we can initialize it at the beginning before we enter the loop, just by using whatever the current X value is. So we do that, and otherwise we do all this stuff. We don't have to render anything when we have a new line character. So now we should be able to say, hello world. Okay, something's wrong. Let's step through it. Let's pick out Visual Studio. Let's run. Let's print what I wanted to print. Hello space new world. Why not? And then we can just break at right. Iterate over it. See whenever we're gonna hit the new line character. And so we have line advances 23, which might make sense. Oh yeah, so that's stupid, as always. We want to advance downwards, which is our coordinate system. Basically means our Y goes from top to bottom. So if we start top, we should decrease the Y. Maybe that was the error. Yeah, see? We have new line again. But you can also notice that the stuff is not properly displaced. As you can see, they are jiggling all over the place, right? Yeah, carriage return, new line. I could do that, but we basically can just ignore carriage return. That's all we need to do. Because sometimes you have carriage return new line, sometimes you have new line carriage return, depending on your operating system. All that kind of nonsense. Something that we should handle when editing, but not really when rendering. Maybe. We'll see. So, yeah, so as you have noticed, maybe, yeah, you can see the characters are all over the place because I always render them exactly where our cursor is, exactly where our XY position is. But we already have the information how to displace individual glyphs relatively to where we need to draw next in order for them to be displayed properly. We're just not using it. So basically, instead of just drawing it at XY, we need to draw them at X plus whatever the glyph X offset is, and Y plus whatever the glyph Y offset is. And that should fix this issue unless I have done some calculation mistakes. Hello, world. I can't. Yeah, the delete is not working. Yeah, so the delete is messed up, but we'll fix that later. Hello, world. Again. Now this looks nice. Yesterday. Yeah, that looks exactly right if you ask me. Maybe not quite, but maybe it is. Yeah, some of these are smushed closer together, but I think they're all in. Since this is a monospace font, we can see that everything is aligned properly. And only the only really difference is, yeah, you see sometimes characters have to start a little later or earlier depending on the specification. So this is nice. This is also a good debugging aid to have these rectangles around the characters for now. But we want, of course, later to remove them. But so far, I would say that was a great success. This is all I wanted to do today, to include STB TrueType and have a function in which we can just print whatever. That's awesome. So, yeah, that's great. I think that's great. But there are some things that I just want to mention for completeness sake. For instance, we have this internal buffer here that we never cleared. Just gonna put into to do release memory. All the other memory also for the file data. All the other memory that we allocate for the font atlas is actually required, but we leak quite a bit of data when we open the file and never free the file memory, and when we create our intermediate glyph buffer and never free this data either. But this could be somewhere on the stack or somewhere globally if we always assume a specific size. You don't have to do dynamic allocation here, which is harder for files unless you know some upper bound of your font files, which is, yeah, just not a good idea, I would say. Yeah. But just a note. And other than that, this worked out quite well. But one thing that we can do now is basically render the cursor. We don't need to enable alpha blending, right? Great, guys. So now the thing that we can do that we couldn't do previously is to enable the cursor. And the way we do it is basically, instead of rendering the whole text, we can render the text in 2 parts. And for that, we can just, just gonna call it left, and it's just gonna copy text, and left count is just gonna be, what's it called? Text cursor, I think. Yeah, just gonna be wherever the text cursor is. That's gonna be left, and so we can just render left first. And now the thing is that we need to return the X and the Y positions if we want to call it again. Otherwise, we overwrite the text. So, but just let me test this out for a minute. What my intent is, and then we can also have the right text, which is basically also just text, but the right base is wherever left base plus left count is, and the right count wherever text count minus left count is. And this way we split up the text in the region before and after the after the cursor. This is not enough if you want to support bigger selections later on, but for now this should do the trick. And let's just see. It doesn't do the trick, by the way, because I still I just wanted to show you the problem. So if I say hello world, and then I move the cursor to the left, the world and the hello will overlap because I render them at the same location again. So like so. See, cursor's in the middle of those two words, but I never increment the X and the Y position. In order to do that properly, what we can do is, in our font, we could basically just return these two, or we can introduce a new concept and call it text cursor. Font cursor, whatever. Too many similar names. X, Y, for instance. And then we can just pass this thing in and increment it. So instead of doing that, this, and it also needs the line start because this might change. So we have the cursor, and then we, instead of doing this, we can do cursor Y, cursor X, cursor line X, cursor advance, like so. This way we automatically increment the cursor, and then we can just do something like and just give it some X and Y location. This is gonna get a little bit more complex later, so don't worry about this trivial function for now. And then what we do is say cursor X equals X, Y equals Y, and cursor line X is just also X. And we have this thing, and then we can do something like auto cursor. Now the word cursor becomes a little bit overloaded because we have a text cursor which specifies where the cursor is in byte position, and we have a cursor which is for rendering. So yeah, if this is confusing to you, think about better names, but I'm not going to do that right now. I'm going to change the names later on anyways. So I'm just going to specify this initial location, like so. Then I'm just going to specify the cursor. This is something that Pushtoy also suggested to Cakes, but he didn't see the benefit of this. Also, what we can do later on is store the font into the cursor and the buffer into the cursor so that we don't have to specify this redundant information all the time. But this might not be what you want to do. But now they should be properly drawn one after the other. If you don't do any mistakes. Cursor should be a pointer because we want to change its content. Hello world. And now if I move the cursor, the position of the text does not change. And now we should be able to, in between those two calls, we should be able to render a proper cursor. And all we need to do is basically just tell the frame buffer where to fill a region. And the region that we want to fill is basically just wherever the cursor X is and the cursor Y. And then we give it some width and some height. Let's just say 2 by line space, line advance, font light advance. And this is not going to be super good, but let's just roll with this for now. And then we should give it a color. Maybe we want to make it some form of green. Who knows? I hated how terminals move your stuff around. I just want to have the same. Oh yeah, it's not called fill, it's called fill box. So we have hello. Oh, look at this. Yeah, the delete is messed up, so we're gonna fix that, but maybe not now. Hello world. And as you can see, the cursor's at the proper position. And if I use the home and end buttons, I can move to these positions also. So this is the basic minimum setup that you need, and all we needed to do is to replace the horrible Windows GDI functions with our own. And you can see Windows could have provided us this location information quite trivially, but it's a little bit harder to get this information out. And also what we want to do is, instead of just rendering it where it is, we can render it a little bit below the cursor position, and the Y is probably okay. But yeah, so the X was the wrong thing to change. I wanted to change. I can do X -1 so that it is if it's 2 pixels, it will align a little better. So I go, and the Y should be, the cursor should be moved a little bit below. And how far below is basically something that you can also gather from your font file. Hello world. This is working like a charm. And we can move along the position and add some stuff into it, as was our previous functionality. I can't delete because the delete is messed up. So, but that's actually all I wanted to do for now. So I would go into the Q&A session. We went a bit over time, so if you people have questions of what we did today, or any questions at all, please feel free to ask. I'm done for now. So please. In fact, I do this. How would I implement a blinky cursor? Nothing easier than that. If that's the bonus feature, we're gonna do it right now. Oh, well, I can do it completely on and completely off right now because we don't have alpha blending. Well, let's just do that. Say I don't have timing, huh? Yeah, that's a bit bad. I don't have time. I don't have time, but yep. Am I gonna implement time now? What do you think, guys? Do we add another 15 minutes? The character buffer is basically just a pointer with a count, and I allocate some space for that. And it's a little more than just a naked pointer. Well, how about I implement time? Since yeah, we can do some questions, and I also implement time. So what's the next? How would you calculate new line offsets based on the font offset? The new line offset is something that the font file actually specified us. So I read that out. So for here you have this metrics that are global to the font, called get font v metrics for vertical metrics, and you get a lot of information. And this is how I calculated the line advance, and you can look up it in the documentation of STP TrueType. see what these values are supposed to mean. So he explains what this means, and then he tells you how to advance vertical position. It's ascent minus descent plus line gap, and I think this is what I'm doing. Ascent minus descent plus line gap times the scale, because this retrieves this information in unscaled coordinates. Yeah. First time. Or did you implement character buffer buckets with memory, or just one big chunk of memory? It's just one big chunk of memory, and I copy it around, and it's basically, I have a giant buffer and I have a text buffer which cannot type in more text than this predefined buffer. Bind it to FPS and ship it. Yeah, I can display the FPS any moment if I implement the timing stuff. Then we can have time FPS and also the blinking cursor. The spacing between lines might be off, you say. Okay. Just hello world. So it's quite big. Yeah, I would say too. It's quite big. So this could be off. Yeah. So I'm not quite sure. So let's see. Maybe I'm doing something twice. I'm not sure. It does seem a bit bigger than it should be. I give you that. I will look into that. So while you ask other questions, I will gonna just implement the timing thing. I will also explain it, but you can ask more questions if you want. I mean, we can also stop if you feel like you've done everything. I don't have this, I guess, but let's fix. No more questions? Are you tired of the stream? So basically, how you would measure time in Windows is by calling carry performance frequency to figure out what the how many ticks in your internal clock, whatever Windows provides you, represent 1 second, and then you can use carry performance counter to get whatever timestamp you have now, divide that by the amount of ticks, then you have this value in seconds, and then you can call carry performance counter once a frame to determine how many ticks have passed from one frame to another. Is what I'm gonna do now, and it requires a very dumb input, which is called large integer, which is essentially this weird union, and all we need is actually the quad part, which is the 64-bit value. So we can just use ticks dot quad part and set a value to ticks per second, for instance. You only need to use carry performance frequency once at the beginning of your application. And then you have another ticks, for instance, here, and then you say something like if you can spell, of course, as always, last time ticks. That's what you get. And then you can call this somewhere in your frame. For instance, here before your frame starts. And just call this large ticks again. And then we have time ticks now. And then we just do a last time ticks. Or better, we have our current time minus the last time divided by best is to interpret this as floats divided by whatever ticks per second we have, and then you get something that I will call the delta seconds, which is how much time elapsed between two frames. And with this value, we can then implement a blinking cursor just by having some kind of value. Let's just say blink. Let's call it blink timeout, for instance, or blink time. And then we increment the blink time by whatever our delta seconds is. And if our blink time ever goes be over 1, for instance, we want to have another static value called blink, or show cursor, show cursor, for instance. And whenever one time unit elapses, we just want to flip show cursor. And all we need to do is if show cursor, we fill the box, otherwise we don't. Let's just see if that works first. As you can see, it blinks a little bit too rapidly, if you ask me. Oh yeah, yeah, because I also need to reduce the blink time by the amount I wanted to test, so to reset it. Don't just set it to 0 again, because this might be a little bit over 1 second, and if you always reset it to 0, you kind of make it go off sync. But if you always subtract the amount, the time interval, you basically keep a more consistent update. This is still broken. What am I doing badly? Oh yeah. Yeah, another thing that I forgot is basically after you computed the delta seconds, you have to update the last time ticks and set it to the current time ticks. Otherwise, you always test the time against the starting time of your application, but you're only interested in the delta. So now it ticks every other second. I don't know if you can see it on the stream properly. Now do a rectangle. I already have a rectangle. This blue thing is a rectangle. What do you want? So this is a blinking cursor, and we can speed it up a little. And the easiest way to do that is just to... I prefer to do something like const blink speed. And just say it's 4. And then when I increment it, I multiply by the blink speed. This way, the rest of the code remains to expect the blink time to be between 0 and 1, and only the update code will change the blink value. So otherwise, you would have to check for a different interval, but I like to keep my timing values between 0 and 1. That's why I do this way. So now it should blink 4 times a second. Are you happy? So what else do we have? Excited for the FPS counter. Okay, people are excited for the FPS counter. Yeah, let's do that. The FPS counter is not that hard to do either. Yeah, how about this? How about a hacky compromise with a FPS counter? Let's just do this. Before we render anything, we want to render the FPS. And in order to do so, I need some text. So I'm gonna sprintf the FPS. I'm gonna have some buffer, which big enough, who cares? I'm gonna sprintf the FPS in this buffer and just gonna say something like some weird formatting here, doesn't matter. Maybe a new line also, and then what we do is auto count. I'm gonna keep this in a local scope because this is just text testing. And all you need to do is to supply the inverse of the delta seconds, because this is how many seconds elapse per frame. So if you take the reciprocal, you get how many frames there are per second. This. And then we need a buffer. Text. It's going to be a string. And the text base is just going to be whatever buffer is. And the text count is just going to be how many characters printf filled in. This should be without zero terminus. Is without zero terminal characters, so we just can't print in the text. Where is... Stop moving the stuff around and stuff giving me repeated... what don't you like about sprintf? Oh yeah, well, of course, a U8, an unsigned char pointer is not a char pointer. We all know that. That would be a terrible, terrible mistake, C++. So now we have some FPS and it's going off the hook. I render with about 1,100 frames per second right now. It's a bit too much. Yeah, a little bit too much. So yeah, hope you're all satisfied. Yeah, if you don't have any questions, I could stop, but I'm happy to continue talking to you guys.